Welcome to another video lecture of OpenStack's astronomy. We'll be looking at Chapter 9, Cratered Worlds. So we'll be looking at in this short video the Moon and Mercury. Now the Moon is not a planet, it's actually a moon, the Earth's moon, but they typically get compressed together or talked about together since the Moon resembles more of a terrestrial planet. So to recall the inner sides or the inner works of the Earth, Venus, Mars, Mercury, and the Moon here, they were all very similar, but smaller worlds cool off faster and harden a lot earlier. So the Moon and the Mercury, being a lot smaller, are now what we consider geologically dead. So at some point they had some activity, but currently today is what we consider they are not active and geologically dead. So 9.1, we'll talk about some general properties of the Moon. And again, it's really just a cratered, it's a cratered world here, bombarded with lots of meteors that ended up hitting it. And you could see that from the surface. So if it's not geologically active, there's not going to be any erosion. There's not going to be any way for the surface to kind of recover itself. And we've gone to the Moon a few times. We've been able to bring back samples, so we know a lot about the Moon. And so majority of these slides will focus on the Moon here. And here's a nice image where you can see the astronaut there. And just a lot of the features there, although the Moon is geologically dead now, we could see here this large rock there. And then around it, just a lot of kind of debris broken down. So, past a wind or erosion there. Also in the background, you could see the mountain line there. So plate tectonics perhaps at some point. So definitely was some type of activity on the Moon, but now is what we considered it to be dead. And the surface has a lot of nice features that kind of resemble that. So here we're looking at one of the mountain's peaks here by Tycho Crater. And so very large mountains there. And you can see in the surrounding areas, not as smooth there, a little bit rough terrain, but a nice mountain line there. Here are some images of both sides of the Moon. If you recall, we're in synchronous rotation, so we always see the same side of it. But you can see one side cratered quite a bit on the right there, and then the left one has fairly amount of smooth sides under those dark regions there, fairly smooth. And again, if it's smooth, that means that it resurfaced itself at some point. So definitely suggests a lot of geological activity at some point. Here are the lunar highlands here. And again, very heavily cratered. You could see that here. So lots of impacts. Here's a closer photo of the lunar mountains here, Mount Hadley. And so very large there, and then you could see some of the very smooth terrain that's on the mountain, so which kind of suggests some type of liquid perhaps flowed through there. They don't think that it has been sculpted by water or ice, though. But we'll talk more about ancient lava flows that we think resurfaced part of the Moon here. And here you can actually see images of that. So the lunar Marias here, that smooth surface. And so when that's that dark region of the Moon, we think some time ago the Moon, large volcanoes erupted and it resurfaced itself. A good amount, they think about 17% of the Moon's surface was resurfaced there during that event. So we'll get into some impact craters. So typically when a crater collides, usually makes a hole that's about 10 times wider than the actual object that came in. And so this is helpful again if we see an impact crater. There's a lot of debris that gets thrown out. So usually looking around a crater, we're able to find, what material that was made of, and what impacted it there. But importantly here is the shape of it. Well, here is actually, before we get into that, here is an impact crater. It's extremely large here, about 75 kilometers in diameter here. So getting bombarded by objects of all different sizes here. But this is what I was getting to a bit more interesting here, is that we could see how the impacts actually affect the region. And so usually you'll have these kind of two larger lumps on the sides there if we know that it's a lunar impact crater. Volcanoes are going to look a bit different. They're going to be a bit taller up and going to have this kind of concave here peak there. So by looking at images, we could kind of distinguish between the two. And image on the right here, you see the lunar Marias in dark there, which we think were just ancient lava flows. So a bit about the origin of the moon. The best theory that we have now is what's called giant impact hypothesis. And so we think a large object, probably about the size of Mars, impacted with the Earth during the formation of the solar system, when there was a lot of heavy bombardment going on. So very violent time. And a Mars-sized object is probably about as large as an object you could have before the Earth gets ripped apart. So very big object that collided with it, perhaps another planetesimal that was going to form there and just collided with it. And so from that debris, then the moon formed afterwards. And so we could look at some of the samples from the surface, and it resembles materials of what the Earth was made up early on. And so most evidence suggests something perhaps violent impact happened. So that leads us into Mercury here, the first planet from the Sun, and it's at about 0.4 AUs or so distance away. And if you recall here, it's very extreme in temperatures, going down from about 800 degrees Fahrenheit during the day, all the way down to negative 280 degrees Fahrenheit at night. And that has to do because it does not have an atmosphere. So even though it's being bombarded by sunlight all day long, as soon as it turns around, all of that heat escapes. And we see that it's just another cratered world here, so much resembles the moon, where we don't see any activity happening currently. So again, geologically dead. But we do see some evidence of past geological activity. And so here we have an image, so topography here, the blue in the center there being deeper regions, and then the red being slightly higher regions. And we could see that there is this large kind of mountain range that goes throughout there. So again, suggesting perhaps some tectonics or some activity there. Again, we have a big large, deeper region towards the center as well. So again, suggesting some activity there. And even towards the bottom right here, we see some regions that are fairly smooth compared to these other regions that are more heavily bombarded with craters. So again, all of that suggesting that there has been some type of activity happening in the past on Mercury. Here again, we could kind of see a crater. You could see the circumference of it somewhere around there, slightly. What makes this interesting is that it's very smooth along the edges, so we don't really see that hole being carved in. So this implies, something partially flooded, right? That impact basin there. So again, some activity that we know of in the past in order for that crater to actually be covered up. We also see these kind of large wrinkles or kind of cuts across. So right about here, we see these large kind of cliffs happening there. And we see that it cuts this meteor impact. So that suggests that it happened after that meteor impact. And we see these large kind of cliffs around Mercury there. If you recall, its core is extremely large compared to the other terrestrial planets. And so we think that cooled down extremely rapidly and collapsed very quickly. And so the surface of Mercury, kind of was swelled up and just went down fairly quickly. And it created these deep kind of cliffs throughout it. So we think those occurred because of the how rapidly it actually cooled off, having to do with its extremely large core.